really try? Thank you. Okay, let's have a look at number 5. Can I borrow this just to read it, please? Express the number 8 as a sum of two numbers such that the result of multiplying their product by their difference is maximum. So, I'll give you I'll help you a little bit by just showing you what possibilities you have here in Excel. Come on. Loading. Right. So, you want two numbers that add up to 8, but when you multiply their product by their difference, it's a maximum. So I'll explain that with some number examples just to show you exactly what's happening here. So let's say, for example, you could have 1 and 7. So do these add to 8? They do. So 1 plus 7 is 8, that's good. And what is their product? Their product is 1 times 7, which is 7, and their difference is 6. So that multiplies to make 42. So another possibility could be 2 and 6. That still adds to make 8. What's their product? 12, and their difference? 4. So this will make 48, isn't it? So what I'll do is I'll just make a little table here. We can have 0, and then we can have 8, and then we can have here, we can increase this one to 1, and then this one here we can decrease it by 1, so we get how far down? Yeah, and then the last one would be 8 and 0. So let's have a look at their product. So here is their product. It will be this one times this one, and that's 0, of course. And then this is their difference. So we'll do this one minus this one, although I don't care if it's plus or minus so much. So the difference is there. And then this is when you multiply the product and the difference. So we get this one times this one. So you can see that they get bigger, and then they start to decrease again, although it's still big down here, but just with the minus. So it looks like it could be 2 and 6, but what you can see here is maybe it's 2.1 and 5.8. I never said in the question that it has to be a whole number like this. But when we get our answer should be at least near 2 and 6. So let's see what we get here. Right, so we'll have the two numbers as x and y. And what's their constraint here? Oh, x plus y has to equal 8. And what is the thing that you want the maximum of? You want the maximum of their product multiplied by x minus y. Now what's the small problem here? Well, you have two variables. Yeah, so what could you do?
Substitute your y.
Yeah. Now, do you see what I meant last class, whereas these all follow the same sort of structure? First you have a constraint, then from the constraint you get, you make something else the subject, and then this goes in to the thing that's of interest to you. So this would be x times y, which is 8 minus x, times x minus y, which will be minus 8 plus x. Minus y is minus this one. So that is x times 8 minus x. Is this alright? 2x minus 8. So that's 8x minus x squared times 2x minus 8. So that'll be 16x squared minus 64x minus 2x cubed plus 8x squared. So that's minus 2x cubed plus 24x squared minus 64x. And I want to make this a maximum. So df dx, that is minus 6x plus x squared plus 48x minus 64 equals 0. Does 6 go? No. Does anything go into all of these?
3.
3 doesn't go into this. Is this right? Is this what you got?
Yeah.
Oh, it doesn't have nice answers. We have to use the formula, I think.
Yeah.
Yeah. So if I just take my calculator out, we'll get 2 answers here for x. So,
Plus or minus 4 root 3
oh, okay, so it's, I got root answers here. So I got x equals 6.309 or 1.691. Now that's only the x. How can I get the y? Yeah, y equals 8 minus x. So y equals 1.691 or y equals 6.309. So actually when you think about it, you're saying that the 2 answers are this number and this number, or the other way around, but of course that's really the same thing. So the answer is 6.309 for x or for y, and then y equals 1.691, or the other way around is fine. Now we need to check that it's a maximum though, because maybe this was the minimum. So how can I check that? The second derivative, which will be minus 12x plus 48. So let's just put this one in. I can see this will be minus 12 times about 6, that's like minus 72 plus 48. So this will be something like minus 30 or whatever. I can see that whatever value it is, it's definitely a negative, which makes it a maximum. It'll be a concave shape. So the answer is 6.3 and 1.6. But what did I say the answer should be near? I said in my spreadsheet here, it looks like the maximum happens at around about 6 and 2. So this first gave me a rough answer, and now I have an exact answer. This will make the maximum multiplication of product and difference then. Okay, so that was a tricky one. What's the next one? I said 6, wasn't it? I think I said 5, 6 and 8, wasn't it? And what's 6 about?
Yeah, the square should be...
Oh, the square piece of paper. So just have a read of it, and then if you can get some of it done, even just like the constraint equation or something, how much progress do you think you made in that?
Yeah. I can't even figure out which.
So 0.
Yeah.
Okay. Right, so just give everyone a minute to read it, and then I'll draw. Okay, can we have a look at it now? Off it goes, Nathan. There you go. Right, so in this question I said you have a square piece of paper. Isn't this what I said? Did I give you the length? No, you don't need it, but I was just wondering if I gave a number. So, what is happening here is you have a square piece of paper, and then in the question I said you cut out smaller squares from each corner. And then what happens is you then fold this up to make a little box. So if you imagine you fold here and folds up here, and then folds up here. So you cut off corners and then you fold up the 4 sides. Can you visualize that? Can you see that? Yeah. So my question is, how much should I cut off from each corner So the box that I have at the end has a maximum volume. So of course, if I cut these too small, I don't get much of a box. But likewise, if I cut them too big, then my box will be very skinny, and that's also no good. Can you see? So there must be some point at which we get the biggest box we can make from a piece of paper. Yeah. So what we need now is some kind of constraint, or at least put in some letters. So what I'll say is I'll cut off x from each corner. So that's like an x by x square. And what I'll say is that the length of this square is L. It's L by L. So, who can tell me how much this is here? Is it L? Is it L minus x?
L minus 2x.
It's L minus 2x. And this side?
L minus 2x.
L minus 2x. And this side?
L minus 2x.
X. Because it's the height of these little...
Oh, yeah.
Yeah. So, what's the volume now? Well, it'd be L minus 2x
Times L minus 2x.
tell L minus 2x times x. So it's not too bad.
L squared.
Hang in there. Hang in there. You're dozing off.
L squared.
You're doing a Hisham now. Just hang in there.
Yeah, but you can...
Although you're doing quite well today. You must have slept a lot last night. Yeah, yeah. You didn't fall asleep once in my class. Yeah.
Well, your class was in the first class.
Oh, this is what makes the difference.
Yeah.
Late night? What was it? What were you watching? Must have, you looked tired. Must have been something good. What was it? Walking Dead, Game of Thrones,
Harry Potter.
Harry Potter. Yeah. Right. So multiplying this, L squared minus 4LX plus 4x squared times x. Yeah, L squared minus 2LX minus 2LX and then plus 4x squared times x. So that will be L squared x minus 4LX squared plus 4x cubed, or in other words, 4x cubed minus 4LX squared plus L squared x. Okay, so just pause for a second there to get this. Yes.
You're okay.
Yes? One sec. I need this. Reasons. Yeah. No, seriously, what were you watching now? I really want to know. Because you're not usually this sleepy in class, so it must have been something good. You're not going to say you were up studying, were you? Oh, reading. What were you reading? Was it Harry Potter? What was it?
No, it's just reading Belfast.
I don't know this.
It's quite an old book actually. It's like a semi-autobiography.
Ah, that's not exciting.
You think maths is exciting?
I don't stay up late reading it.
They are they doing it?
Yeah, I don't read maths, I do it. Yeah. Alright, so what do we need here to find the maximum? What do we need? How do we get the maximum here? Derivative. So what's the derivative here? Now just be careful with the L. You need to think of the L like a constant. So what's the first one?
12x squared.
12x squared
That's 8.
Minus 4.
minus 8L
8L
x
Plus
plus L squared. No, because this is like a constant and this is the x. Equals 0. Now, the problem is we cannot use the calculator or factorize here. Why not? The L we don't know, so there's only one thing I can use, and what's that? The minus b formula. So I have x equals minus b plus or minus the square root. Well, that'd be L in the answer, so we can't avoid that. Minus b plus or minus b squared minus 4ac all over 2a. So that would be 8l plus or minus square root, what's that now, 16, is it? Actually, that's not too bad. 16l squared has a root. Yeah, it's going to be 8l plus or minus 4l over 24. So the two choices are 12L over 24 or 4L over 24. So that is X is a half L or what's that? A sixth L. So this is how much of the length we should cut off. One of these answers doesn't make sense. Which one? The half L. Yeah, but why does this not make sense?
Because it's
What-
half the length.
Yeah, if you cut off half the length from each corner,
You don't have a box.
you don't have anything.
You don't
Yeah.
have a quarter of a box.
You have nothing.
Well, how do you break the box? Off. That's
This is the one that makes sense because it says you should cut off a sixth of the length from each corner. A sixth of the length, whatever the length is. So to make the biggest box possible, cut off 1/6 the length from each side and then fold it up. Okay, so that's number 6, and what's number 8 is the last one I'll do from this.
The car.
Is this at the crossroads one?
Yeah.
Yeah. Okay. Any progress on that one? Look how far did you get?
I drew a car.
Did you draw you in the car? No. Progress? How far do you think you got? Yes, good. And stop there? All right, well, you had the right start. So let's do number 8 now. So what's the information? There's a car heading to the east, is it?
Oh, north.
No.
From north.
From north. How fast?
The car is
10 meters per second, and it's at the crossroads?
Yeah.
Yeah. And it's at 10 meters per second. And then there's another car heading towards the crossroads
Yeah, 14 meters.
from the east. Going how fast? 14 meters per second. And it's a distance of 84 meters away. Yeah. So you can see that the cars will not meet, will they? They won't meet. Now watch this. At the very beginning, how far away are the cars? 84 meters. Yeah. As time goes by, like here, they'll be closer together. And then they'll be here, but then after enough time, when this is very north and this is very much to the west, they start becoming further apart again. So if you were to look at their distance, they start off at 84, they get closer, and then they get further apart again. So then the question is, what's the closest they were to each other? Do you understand? So let's have a look at what equations we can make here. Right now we don't have any formulas. So if you look at some time that has passed, let's say t seconds later, let's say 2 seconds later, how far has this car moved? This one. Yeah, so that's 20. 3 seconds later, how far has this car moved? 30. So t seconds later, how far has this car moved away from the crossroads? 10t. Now let's look at this car. At the beginning it's 84 meters away. 1 second later, how far away is it from the crossroads? 70, yeah. Another second later? 56. Isn't it? 56. Yeah. So, at t seconds later, how far away is it? 84 minus 14t. That's how far away it is from the crossroad after t seconds. Yes? Now, this is okay so far. Now you were right, you have to use Pythagoras because what we're looking at is the distance between the two. Yeah.
That car from the east, isn't it going this way?
To the west.
Yeah.
Yeah.
You draw it in.
No, sorry, this is the distance.
How come you're subtracting for this one and you're not for the...
But you told me this.
Yeah, I know, because I was telling you what you were asking for.
Okay, so why did I subtract here, is it?
Yeah.
Where is this at the beginning? At the crossroads?
Zero.
It hasn't. It starts.
No, it's not, yeah.
Oh, nobody told me that. All right. Thank you. This one starts 50 away from the crossroads, and this one starts 84. Right. So all I need to do to change this is put 50 plus this.
Why?
No plus.
Wait, hang on. Is it starting on the north or on the south?
No.
It's starting up here. And is it heading north or south?
No.
Heading south.
South.
Each one down.
May I have the question?
It's heading south.
No. I'll read it.
It's heading to.
No. It's all okay. I'm going to read it now.
No.
That's very kind of you, but it's okay. I'm going to read it
It's
now.
under control.
It's under control. A car is 50 meters from the center of a crossroad and heading towards it from the north. So it is here. It is 50 meters away, and it's heading towards it at 10 meters per second. Okay. Another car at the same time is 84 meters from the center of the crossroad and it's heading towards it at a speed of 14 from the east. So it's heading here at 14 meters per second, and it is 84 meters away. Now, we want to know what is the shortest distance here. How long until this car gets to the crossroads? 5 seconds.
Yeah.
How long until this car gets to the crossroads? 6. So will they meet at the crossroads? No. This car has already passed it by the time this one gets to it.
Because 10 meters there.
10 meters, yeah. But that might not even be the shortest distance, because the shortest distance might happen as they are approaching the crossroads. So it should be somewhere in the neighborhood of 10 as a number. Right, so the height here is 50 minus 10t.
Wait,
Because?
Because at the beginning it's 50 away, then it's 40 away, then it's 30 away, 20 away, 10 away, and at the crossroads. So the formula is the distance away from the crossroads will be 50 minus 10t. Each second it's losing 10. And then this way, what will it be? 84 minus 14t. And we care about this distance here between them, which we can get from Pythagoras, which I'll call this distance, I'll just call it y, for example. So y squared equals 50 minus 10t squared plus 84 minus 14t squared. Right, I should expand this. Y squared equals 2500 minus 1000. 2 times 50 is 100. 100 times 10 is 1000. Plus 100t squared. 84t squared. 84 squared is 7056 minus 2352, and then lastly 14 squared is plus 196t. So this will be how much t squared? So that would be
So you're missing a T or something.
sorry, I lost my t on this one.
Yeah.
Okay, so minus 1000 plus 196 is minus 804 t squared minus 3352 t 7056 plus 2500 plus 9556. That's the y squared.
It's 10 minutes for the vocabulary.
Huh?
10 minutes for the vocabulary.
We've got loads of time, don't worry. What you worried about?
No worry.
Good. Okay. Oh, don't worry for them. Right. We got this much? So we want the minimum distance. So what do I need to do next? Yeah, but I don't quite have distance here. What is this formula for?
Nine.
The distance becomes
distance squared. So what should I do? Root, but we don't have any formula for this type of derivative. But I want to give you a concept here, if we just look to the side. So, imagine I have these numbers, 3, 2, 1, 0, I don't know, 1, 2, 3 for example. Where's the minimum number here? At 0. Now if I square these numbers, 9, 4, 2, 0, oh sorry, 1, 0, 1, 4, 9, where's the minimum? It's still in the same location, isn't it? Where's the maximum? At the end, which is still the case when they're squared. In other words, if I square something, my goal is still the same. If I want to find the minimum, it's the same as finding where the square will be minimum. So it's perfectly fine to find the time by minimizing this instead of the y. It's much easier to minimize this. So dy squared dt is minus 1608 t minus 3352 t. Is that right?
No, minus 335.
Oh yeah, sorry, minus 3352, no t there. Yeah? Now I think I must have made a sign mistake somewhere, because I should have sworn this should be positive here. So let me just double check. 2500 minus 1000 t plus 100, and then 84 squared. 84 squared is 7056. 14 times 2 times 84 is minus 2352. Minus 14 squared is 196. T squared. Oh, sorry, my t squared is wrong, is it? Yeah, sorry, I just need to fix my t squared. I need to add 100 and 196. I accidentally added minus 1000. So I'll just fix that by changing this. It should have been 296. So what will the derivative be? 296 times 2. What's that? 296 times 2, 592. Okay, so let's get the time here. The time will equal 3352 divided by that. So the time is at 5.66 seconds. Now I don't want the time, what do I want? Distance, so I'll just take that,
Wait, what did you do, sorry?
put it back in there. Just solve this, get the t from it. Yeah. 50 minus 10 times 5.66 squared plus 84 minus 14 times 5.66 squared. Square root the answer. And I get y equals 8.14 meters.
Close to 10.
Yeah, but smaller than 10 was my point. So after 5.66 seconds, the cars will be 8 meters apart. This is the closest they'll ever get. Yeah? Do you want to look at your vocabulary now, or do you want to look at that turning point question? Huh? How? Give me the question. Let's see how long it is. Is it just? Oh yeah, I can do this super quick. So, guys, be quiet so I can do this quickly. I want the maximum of this function. A half e 2x minus 2e x plus 1 plus e squared x plus 1. Nathan, be quiet. Right, dy dx. No, before dy dx, this is the last one on the turning point question. I got y equals a half e 2x minus 2e ex plus e squared x plus 1. So I use the first rule of powers to split this. This is like an e1 here.
Oh, okay.
Yeah, now do you remember the derivative here of ekx? Kekx. So this will become what?
E to the power.
e2x. What will this become? Minus
2e
ex, because ex doesn't change. And what will this become at the end?
E squared.
E squared. Why? because the e squared is like a constant on it. And what should that equal? Zero
Zero, yeah.
for maximum or minimum. Yeah?
You said that when you split it up, you can write it as minus 2e1 minus 2ex.
No, I don't say that.
Please.
I said what? No, you're saying this right. What did I say?
That minus 2ex can be written as minus 2e1 minus 2ex.
No, multiplied by.
Oh yeah. Yeah.
Okay, I'm continuing now. So we've seen this type of problem before. What type of equation is this? It's actually a quadratic in EX. And you know what? Just to save time, I'm just going to hit this in on the calculator.
No.
So, yes.
No, solve it, please.
Just put the numbers in. So what's the A? What's the A? 1.
Wisdom of topic.
1 is the A. What's the B?
Minus 2e.
Minus 2e. And what's the C? E squared. So you get 7.389 or 2.718. Now this is for EX. How can I get X?
Yeah.
I use log.
Yeah.
Log of this will be 2 and log of this will be 1. Yeah, that's it. Now let's have a look at vocabulary. I told you to be quick.
She did it exactly.
Oh. Can you type out your vocab?
I'm not worried about my vocab.
Well, let me just hear what words you pick. You have to pick some words. How many words?
10.
10 words. Okay.
Want to start with me?
Start with the guy who said he's not worried. No, let's prioritize. Who feels they are really worried? Only Hisham? Well, we'll just start from the left here. Do you have your 10 words? Do you have your 10 words?
Let's wait. Just hold that.